Hi guys, this is Mr. Ego, and today we're going to do the computer-based practice test for the Geometry EOC. Okay, we're going to do session 1. Let's start. Again, we're in the fsaassessments.org computer-based practice test material. I'm going to go straight to take the computer-based practice test. This is the way you would start the test. We're going to sign in as a guest. All right, I'm not changing anything, just read through all, as a guest. The whole idea is to practice. Grade level is 8th grade. Okay, that's when it's offered geometry honors. We scroll down, Geometry EOC practice, no accommodations, no change of anything. Select. You can change this, check the settings, you can do all this, or go straight to the test. Same thing the day of the exam. All right, so let's start. Question number 1. Again, you have tools on the top. In the figure, so we have a diagram here. They're saying AB parallel to CD, BC, so AB, the vertical line, parallel to CD, and BC parallel to AE. All right, all those lines are parallel. The only one that is not parallel is this one. All right, so let's see. And on the bottom, we have, so let's make this screen bigger. There you go. And then we come back. I think we can just close it and then everything comes back. All right, excellent. I got the idea. All right, so the whole idea, remember, is to, our answer is going to be here. The question is angle, find the measure of angle BCD. Angle BCD. All right, so this is the angle that they're asking me for. Let me get the pen. Here we go. All right, BCD. This is the angle that they want. They tell me that this is parallel to this is parallel to this. Now, ABD. So I'm going to call it with a point. That's ABD. This is ABD, 3x plus 4. BCD, 6x minus 8. BCD. All right, so the actual angle, that's the one they want me to know, this is the little arc, 6x minus 8. EDF, the here in the bottom, this angle, EDF is 7x minus 20. All right, so what's the idea? What do we need to do? Again, all these lines are parallel to each other. Okay, that's the only thing that they're saying. Remember all the names, alternate interior angles, corresponding angles. Okay, I'll link a video underneath. So the idea is the following. This angle and this angle, where you have the B and D, those two angles are congruent because you have transversal and you have two lines that are parallel. So this is the same as this. All right, and therefore, now remember, these two lines are parallel to each other. Therefore, this little arc is the same as this little arc. Okay, and now I brought everything on one angle. And if you notice this, which I'm going to do right now, okay, if you have two arcs here, you have a dot here, and you have one arc here, this is a straight line. That means this whole thing is equal to 180. So the sum of those three angles equals 180. What three angles? The dot, which is 3x plus 4, plus the one arc. The one arc is 6x minus 8. And 7x minus 20, which is angle EDF, which is two arcs, 7x minus 20. All of them make this straight line. Therefore, the sum is equal to 180. All right, from there, what I'm going to do is I'm going to find the value of x and then plug it back into BCD. BCD is this, is the one that I want. So let's find the value of x. 3x plus 6x is 9, and 7 is 16x. Let's add the constants. 4 minus 8 is negative 4. Minus 20 is going to give me negative 24. E2 equal to 180. I gotta cancel the x, I'm sorry, leave the x by itself, so cancel the 24 by doing the opposite. 24 minus 24 is 0. Bring down the 6x, and now I have 204. Okay, and now divided by 16, divided by 16. Okay, make sure you use calculator. All right, that's 10, that's 60, that's 44, and my answer is, calculator's back, so 204 divided by 16 equals 12.75. Again, is this my answer? No, they want me to find the value of angle BCD, which is the one on the bottom, angle BCD. And now BCD is 6x minus 8. 6x minus 8. 6 times 12.75 minus 8. Alright, I put this in the calculator. 12.75 times 6 gives me 76.5 minus 8 is going to give me 68.5. So I'm going to key in here 68.5. Let's get rid of this. Let's get rid of this. And I'm going to put here 68. Nope. No. Where's the eraser? 68.5. That's my answer. Okay, I have my answer. Let's go to the next one. All right, let's erase this. First answer. Next question. Okay, so let's bring out a pencil. Actually, we don't need a pencil. Matches building with the geometric shapes that can be used to model it. Oh, okay, great. So what geometric shapes I have here in this? So guys, if you notice, this is you see the little circle right here, the arc. That means this is a cone. So that means this is an arc. That means the base is a circle. If the base is a circle, that means that this shape is a cylinder, the body of the building. And the top, look, is an ice cream cone, backwards. Pyramid has to be straight, you know, a rectangular base. Or rectangular prism, it has to be like some kind of, like this one, for example. You see, straight line. It's like a rectangle here. So the last one is rectangular prism. So this is my answer. But this corner, these towers on the corner, that's a circle on the top. You see this? This is like a circle right here. So these are cylinders. All right, those are cylinders. All right, 2. Oh, what about this one? So I draw my pen. So number 3, the third drawing here, let's look carefully. So we have cone, cylinder, pyramid, and rectangular prism. Okay. First of all, you see this shape in front of the building? This is circular. This is a circle base. If this is a circle base, then this shape is a cylinder, and cylinder is our second one. All right. If this is a cylinder, this thing on the top, the base is a circle. If the base is a circle, then this shape is a cone because the base is a circle. All right. Now let's go for the main building. I see this is straight line. Look at the bottom. Here's a circle, which is our cylinder, straight. Okay. So if those segments are straight on the sides, that means that's a rectangular prism. Obviously, this is going to go deep, right? Because this is a building. So this bottom, the whole bottom base, is rectangular prism. Look at the tower. Straight lines. Rectangular prism, which is our last one, I believe. All right, here's a pyramid. But this shape, remember, this tower, straight lines. This means it has a square or rectangle as the base. Because it has a square rectangle as a base, and it has this shape, then this is a pyramid with a rectangular or square. This is a square pyramid. Okay. When it's a circle, it's a cone. When it's a square or rectangle, then it's a pyramid. Keep that in mind. And that's number 2. Next. In the diagram shown, okay, we have chords A, B, and C, D intersect at a point E. The measure of arc AC, where's AC? AC, okay, the number is given right there. The measure of arc BD is 2x. BD, here is 2x, that's the arc. And the measure of the angle AEC is 4x. AEC. Something to consider is that this angle is not a central angle because it's not right in the middle. Okay, so let me use something from the booklet that I have linked on my underneath. Okay, so remember this just to make sure. Geometry, right? Okay, I'm going to use that because here you have all the formulas, guys. So when you're working on this, use them. I'm looking for circles. Circles, 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 circles. More circles. Here we go. Look at this drawing. Inside angle. Okay, two intersecting chords. So you add the arcs and you divide by 2. That's the angle. So angle 1 is Rx plus Y divided by 2. That's what we have. Okay, where is my, here we go. So my angle, by the way, the question is, what is the degree of the measure of angle AED? AED is this angle for X. So we got to find the value of X somehow, and then we type it in. All right, so let's do the work and then we type it in the bottom. So let's find the that angle. How do I find the angle? Remember, they're saying that that angle, let me get my pencil, that angle AED, which is 4x, is equal to the sum of the two arcs, which is 120 plus 2x divided by 2. They said add the arcs divided by 2. Now what? Now this is an equation. All right, cool. How do we solve for x? We have x's on both sides, but first of all, I have these two dividing. So let's do something simple. This 2 divides the 120. 120 divided by 2 is 60. But that 2 also divides the 2x. The 2 divides any term on the on the top. So 120 divided by 2 is 60. 2x divided by 2 is x. And now my equation seems better. I have x on both sides. When you have x on both sides, cancel the smallest one, or the one on the right side. Minus x. 4x minus x is 3x equals to 60. All right. Divided by 3. Divided by 3. X equals 20. Is this my answer? No, it's not. Okay. Remember, your answer, we're looking for angle AED. AED. Hold on. So x is 20. All right. I have the work already. So let's clear this out so we can scroll down. All right. Let's clear this down. X equals 20. AED. AED. Oh, so no. AED. Okay. All right. I had a mistake when I was thinking. So they're asking is for this angle. AED. But I know that my x is 20. So let's find out how much is this. This is 4 times 20, which is 80. So if that angle, if this angle is 80, and this is a straight line, which means the whole thing is 180, then the other angle, which is AED, has to be 100. 80 plus 100 equals 180. So the angle they're asking me is AED, which is 100. Very nice. Let's let's get rid of all this. Let's scroll down, and the angle is 100. Enter. Move on. Number 4, triangle SRT is shown. Okay, I have that triangle. Let me see what is the information at the bottom. There are 3 highlights in the paragraph that shows equations or phrases that are missing. For each highlight, click on the correct equation or phrase. The vertices of triangle SRT, so S is 1, 4, R is 2, 2, T is 1, 3, okay. A reflection across the line. Let me see what the choices are. Oh, so they gave me 4 choices. X equals 4, X equals 6, Okay, let's write those choices. X equals 4, X equals 6, and the other two choices are negative x plus 5, negative x plus 6, negative x plus 5, negative x plus 6. I'm sorry, y equals negative x plus 5 and y equals negative x plus 6. Those are my choices. Alright, so let me bring the other information here. So these are the options for the second one, negative y equals 6, 8, negative x plus 10, negative x plus 12. Okay, let me cancel this. And now let's look at the options here. The options for the last one are congruent, parallel, perpendicular, and similar. Congruent, parallel, perpendicular, and similar. Got it. Alright, let's move on. So now, they have 3 blanks. Okay, the vertex of this is this, a reflection. So this is the first reflection. And then across the line, okay, it's the same as the translation of 4 units to the right and 4 units up because the lines are. Okay, so my last thing is I had to say they're parallel, perpendicular, congruent, or similar. That's the last question. Excellent. All right. Okay, so there's 2 reflections. A reflection across the line and then across the line. So it's going to be 2 reflections, the same as the translation of 4 units to the right and 4 units up, because the 2 lines are, and we got to find that. So let's do all the work. So they're saying that this translates 4 to the right and 4 up. So let's change a different color. I don't know. Let's do, you know what? Let's go black. Yeah. So 4 units to the right, 4 units up. Okay. So here we go. So if I go 1, 2, 3, 4, 1, 2, 3, 4. Let me get here. 1, 2, 3, 4, 1, 2, 3, 4. This is going to be S prime. The R, 1, 2, 3, 4, 1, 2, 3, 4. T, 1, 2, 3, 4, 1, 2, 3, 4. So this is T prime and this is R prime. Okay? And this is my new triangle. Alright. Okay. Alright. So that's what I want. And that's going to be obtained by doing 2 reflections over these lines. Okay, so let's go over the lines first of all. Let's go over those reflections because those are, they don't make sense too much for some of them. Okay, x equals 4. X equals 4 is this line. That's my first reflection. Okay, so they're saying that if I make a reflection across this line, if I make a reflection across this line, my reflection is going to be here. So 1, 2, this is going to be R, this is going to be T, and this is going to be S. Okay, and then they say it's going to be a reflection along one of these lines. But again, if I reflect this around one of those lines, it's not going to have, there's no way I can turn this by reflection like that because my reflection, whatever might be the case, is going to look something like this, for example. Not in this position. Okay, so that's what I'm trying to solve. So x equals 6, x equals 4, x equals 6, I cannot do this kind of reflection. It doesn't make sense whatsoever because my second reflection, I'm not going to be able to get the same triangle. So it's going to be one of these 2. All right, again, I need to look on those 2 reflections at the same time. So first 2 answers, that don't work. Let's go back to, so first 2 don't work. Let's try the next one, negative x plus 5. Negative x plus 5, my slope is negative 1, my y-intercept is 5. My y-intercept is 5, my slope is negative 1. So negative 1 down, 1 to the right. 1 down, 1 to the right. 1 down, 1 to the right. So that's the line that I'm trying to draw. That's going to be the reflection across this line. Okay, if I draw a reflection across that line, that means my new triangle is going to be something like, it's going to be right there. This point is the same point. This point is going to be over here. And this point is going to be here. So it's going to be something like this. Okay. And then I had to reflect this across a line. Therefore, my line has to be some kind of diagonal, okay? So it's not going to be the y equals 6 because y equals 6 is a horizontal line. This line is y equals 6. If I reflect this on the top, it's going to be around here. Y equals 8 is going to be around here. If I reflect this on that line, it's going to be even higher. So none of these two work either. Alright, so let's go back. So right now we're just crossing ideas. So I'm using the first one, I'm using this, y equals negative x plus 5. This is this green light. And if I want to reflect this, another one, it has to be some kind of diagonal here. Alright? How far? It's going to be, has to be between these two, halfway between this point and that point. So that means I had to find a line of reflection that is be a diagonal halfway between this. Halfway, let's take any point. Let's take this point for example. 1, 2, 3 steps. So the halfway, the distance between this point, this is 3 steps, so I'm going to have 1.5 away. So my line has to go through here, but again, it has to have the same, it has to be a line parallel to this, therefore it has to be negative x. So I'm just going to go through these points. Let me get up this. Alright, so it's going to go through these points, those corners. Okay, so that means I'm going to be touching at 9. So my y-intercept has to be 9 on my line of reflection. Well, what kind of lines do I have? Y-intercept is 10, y-intercept is 12. Therefore, this is not going to work out because in order for this one to work out, my second line will have to be some kind of y equal negative x plus 9 because my y-intercept has to be equal to 9. Because I don't have that as my second choice, then this one is not an answer as well. So this has to be the final answer. Okay, so let's try this one. Let's try this one with, I guess, let's do go red, I guess. Okay, so negative x plus 6. Negative x plus 6. So negative x plus 6. I have to erase a lot of this stuff. All right. So let's erase that, the triangle, and the green line. There we go. So now let's try negative x plus 6. Negative x plus 6. So I'm going to go, my y-intercept is 6. All right, I'm graphing this line. And my slope is negative x, which is negative 1x plus 6. This is what I have. Remember, this number is your slope, and this is your y-intercept. Okay, the 6 is your y-intercept. So 6, and my slope is negative 1, which means I go down 1 to the right 1 down, 1 to the right, down to the right. So I'm going to go this diagonal. All right, let's draw that line. So that's going to be that's this line. Okay. All right, cool. Now let's find out what triangle do I get in the other side. So this point is here. This point is here. This point is here. So this is my new triangle. Alright, that's my new triangle. Now I'm going to find my second line. So I know this is my first answer. Now let's find the second line. As we discussed, if I do the horizontal lines, if I do any of those two horizontal lines, it doesn't make sense because my triangle will be something around here, right, on the top. And that doesn't make sense whatsoever. So none of these two answers make sense. Alright, so let's cross this and let's cross that. So it has to be one of these diagonals. Okay, let's find out. So now that we have the triangle, let's get some different color. There you go. Okay. So let's find the halfway, the distance between any 2 points. I can use the R. Remember, this is R, or this is T, or this is S, right? That corner. Let's use this one. So it's only 2 steps, right? 2 steps. That means this is halfway. And it has to be a diagonal as well. So that means I have to touch those points on the diagonal. Oh, what point am I touching? All right, I think that's clear now, right? If I connect these points, my line, here we go. If I connect those points, then you can see that, yeah. So What's the equation of this line? Simple. What's my y-intercept? 10. 10. And my slope is the same because it's -1. Therefore, my answer is this. Let's double check. So this is point T. 1 away, 1 away. Look at this one. 1.5 away, 1.5 away. What about the R? 1 away from here to the line, and from the line to here is 1 away. Alright, therefore this is my answer. Now, what's going on between line red and line green? Are they similar, are they congruent, are they perpendicular, or are they parallel? They're parallel, right? So those are my answers. Y equals -x plus 6, y equals -x plus 10 on the second choice. Let's scroll down and let's do that. Okay, so here we go. Let's go here, and we said that this one was -x plus 6, right? Okay, my second answer was -x minus 10, yes, and my third answer was because the two lines are parallel to each other, and those are my answers. All right, let's go to question number 5. Oh, proof. Okay, a proof with some missing statements and reason is shown. Okay, PQ is a parallelogram. Okay, that quadratic is a parallelogram. PQ congruent to QR. PQ congruent to QR. Okay, we have to prove that this is a rhombus. Guys, in order for us to prove a rhombus, remember, what do we need to do? We need to prove that all the sides are congruent. That's it. Okay, and I see where we're going right now. Let's see what the informational questions are asking me. Drag the correct statement from the statements column and the correct reason from the reasons column to the table to complete line 3 of the proof. Oh, so it's only one line that we have to do. Guys, again, be careful with this. Proofs, make sure you read carefully what they're asking you. They're asking me to do the whole proof, okay, because I think there's too many lines and too many blanks in this thing. So they're asking me line 3. All right, so let's see the statements. PQ congruent to SR, PQ congruent to SR, all right, the bottom and the top are congruent. Makes sense because that's a parallelogram. PS congruent to QR. PS congruent to QR. That makes sense because opposite sides of a parallelogram are congruent. Remember, this is a parallelogram, so opposite sides are congruent. That makes sense. So this answer makes sense. PT congruent to TR. PT congruent to TR. Oh, the diagonals being bisected. Okay, guys, but one thing they have to be careful with is what they're asking me. They're asking me to be a rhombus. Okay, so they're asking me for the sides for the most part. Also, rhombuses have the diagonals are perpendicular to each other. If we see the diagonals are perpendicular here, then we can look at it. For the meantime, we need to prove that all the sides are congruent. Okay, so keep that in mind. So this is the diagonals bisect each other. Here they're saying that triangles, doesn't make sense too much. Angles, SPQ, okay, opposite angles are congruent. All right, that's fine. But again, where are we going? We're proving this as a rhombus. So we need to prove that all the sides are congruent. Look at this. PQ congruent to QR, PQ congruent to QR, which is congruent to RS, the bottom, which is congruent to SP, the left side. You see that? We have to prove that all sides are congruent. So let's keep the pattern and the sequence in a logical process. Given, the first two lines are this information, PQRS parallelogram, and the next line will be PQ congruent to QR. PQ congruent to QR. So guys, let's analyze something. When this is a parallelogram, and let me get a pen right now, which I got this already. This is nice, by the way. So this is a parallelogram. That means the top and the bottom are congruent. And the left and the right are congruent. That's from this one, from my parallelogram. But then they say PQ is congruent to QR. PQ congruent to QR. Oh, they're saying that the top and the right are congruent. So if this has 2 marks, then I'm going to put 2 marks here. Oh, but opposites, remember, they're congruent as well, so this has two congruent marks. Now what? What do we have? Now all the sides are congruent. You see that? So what we just did was, when we had a parallelogram, opposite sides are congruent, that was the proof that we needed. That was the proof that we needed. PQ congruent to SR, remember the opposite sides? And look at the reasons. Opposite sides of a parallelogram are congruent. So my reason, my statement is, here we go, let me erase all this. My statement is PS congruent to QR. PS, where's that? PS congruent to QR. There we go. That's the one. And why? PQ, SR, PQ, SR, top and the bottom. PS, QR, left and right. Yes. Opposite sides are congruent. Opposite sides of a parallelogram are congruent. And that's my reason. So that's my statement and that's my reason. All right, nice. Are they asking me to complete the proof? No, only for number 3. But after that, all sides are going to be congruent. So I don't have to finish. That will be it. Remember, always concentrate on your question and see what is the logical process from the beginning all the way to your final answer. Guys, I'm going to stop here. We got, a little bit long, so I don't want that too long. Next video, I'll continue on question number 6 from the first section of our computer-based test. Please like the video if you understand it, like the video, subscribe to the channel, and turn off the notification bell so you can get notified when we got the next video. All right, thank you for watching. Take care, guys.